you beautiful people, this is Unclecode, the man that built Crawl4ai for you, the lovely crawler engines. So, what we're going to do today is going to be very fun, and we're creating a real project using Crawl4ai, and that is to build your own SERP API or SERP API. I'm pretty sure that many of you know about this because these days this is becoming very useful. If you're building a large language models and you're building an AI assistant on top of that, you need to search over the internet, you need the real-time data, you need Google search result. And then what you're going to do, you're going to use a platform like here, you pass your parameters, you get back search results, the search result that you have in Google, you know, when you search for example, Apple or anything else. And then when you get all those kind of information as a JSON, you get those links and then you extract those links and then you use Crawl4ai to crawl those pages, then get beautiful data marked down, pass it to your language model. You may want to answer as a users immediately because time and fast and efficiency is important, right? But now it's interesting because you're going to see how you're going to create your own SERP engine. Well, don't get me wrong. I really love these products. I work with them many times, but also I like that to give this power to every single one of you to build your own tools, especially if you're starting a project, you're a researcher, you're in students, or you're a company, you want to really be efficient, a startup company. So that's a very good way. This is what we're going to do. Let me run first an example of this code. Okay, here, I'm going to run. You see, I have, at the end of today, we're going to have this code. We'll talk about it. And then we pass this Apple Inc., let's say. I am going to run it. And that is correct. Yes. Okay. We are searching right now in the Google. We'll get back the results immediately. Look at that. So beautiful. Perfect. You get the organic results. And also, as you can see, we have top stories. It's empty because for some reason, today that I'm recording the video, Google does not have any top stories for Apple. Okay, maybe because I don't know, but sometimes there's top stories, and SERP API does not return back top stories as far as I know. Anyway, when you build your own, you can do anything you want, and then the queries. So we're gonna have something like that, and you're gonna have fun with it. Okay, if you are ready, this is the beginning of our journey. Let me back to my slide. Okay, and then we're gonna dive into the coding, and also at the same time I'll take a chance to talk a bit about Crawl4ai, and at the end of the day you have this. So now click on the links if you are watching this video on Twitter to go and watch the rest on YouTube. If you are in the YouTube, so you are here. That's it. The first part, introduction, is down. I did introduction overview, and now we're gonna go and talk about I think I did a quick demo as well. I took a video about a SERP API. So I think I passed number 1 and 2. We're going to jump and talk about the number 3 and see you soon. Hello again. So if you are continuing watching in the YouTube, so stay here, or if not, welcome back from Twitter. This video is going to be long. I think many of my videos are getting long. I divided into chapters. You can jump, those parts that you know it already. Because in this video, I want to have a little introduction to Crawl4ai, a quick review, a recap, and then go through the SERP. So let's see what do we have here. We talk about what we're going to do, and then okay, we are very clear about the SERP dashboard. This is what we're going to do. And then, and I gave you an example of the results, the code. This is what you're going to have at the end. Now we go with, okay. Before I jump to the first solution, which is not my favorite solution, means using large language model instantly, the lazy way. But let me give you a little bit taste of Crawl4ai. Crawl4ai, I started Crawl4ai with one primary goal. I wanted to turn every links to a very clean and efficient markdown. When you look at the pages, there are a lot of information over them, information that you really don't need. You're searching for some things and you want to fit that data to your language model. If it's a RAG system, it's a fine tuning, whatever. And then, or maybe it's just a language processing, natural language processing, you need that data. You need to kind of markdown. Markdown is a beautiful format. They cut all the kind of things and you get it. So I couldn't find something cool and I built it myself. And to do that, I wanted to also focus on efficiency and the speed. Speed is very important for me. That means I want to, for example, have thousands of the URLs, I want to instantly get the information that I wanted. And future is going to be based on that. If you want to have real-time agents or AI system, they need access to public information, or maybe you're a company, you have a lot of domains and information and often HTMLs, and you want to crawl them quickly. That's your solution. That's your approach. So let's dive into a little hello world of Crawl4ai. Okay, I do have two hello word, little hello word and a hello web. I decided to call it hello web, and now I'm keep saying hello world. And look at that, even here around. Okay. Well, anyway, I have two little hello web example. Let's look at the very first one. If you are new for Crawl4ai, you're gonna like this. So what you're going to do is this. There are a few classes that you have to always remember. One is async web crawler. When I started, it was really synchronous. So then for a while I had two versions of it. That's why I had web crawler async, and then the sync crawler gone, and still the name is there. You will see again the same thing here. Anyway, you create an object of async web crawler. If you create an object, you have to call start function. Start function instantiate a browser for you and get it ready for you. And then when you're done, you have to close it. But if you use this context, asynchronous context, well, it does everything for you. This is your choice. I'm going to use both in this tutorial. Then, well, I call a run function, which is an asynchronous function, and the result is an instance of crawl result function. So that's a second function class that you need to know. That is enough to have a kind of little usage of the Crawl4ai. And this one comes with a lot of things. When you extract the results, you extract links, videos, images, structured data. If you use, for example, some of the algorithms that create the structured data, we're going to use in this video, and many more things. And then, and including the markdown, then you pass the links URL and down. Then you can just write result down. You're going to get a lot of, properties here. Links, media, markdowns, images, download file, metadata of the page. Well, you can see again some weird things. We have markdown and markdown underline version 2, which in the new version, which is coming by the next week, we're not going to have this. Everything will be marked down. So you can ignore this part. If you're watching this video after, I think it's going to be 6th and 17th February 2025. So this, perhaps you don't need to do anything. And then you see that I have a markdown objects and raw markdown. It's just a pure markdown. We have better markdown as well. And we have different flavor of the markdown. And that's it. This is the little hello web. But if you want to go a little bit, get more into it, you can see that now we have, so just let me say here, not jump. Okay. Any question? Yeah, definitely you can do that. That one also is possible. Yes. I'm pretending I'm hearing your question. So then this is done, right? Clear? I can close this and I can open the hello web. Okay. You see here it still is the same. This part, no difference. This time I'm passing a configuration. So we have now the third important class. So the first important class was async web crawler. The second important class was crawl results. And the third is crawler run config. This is the holy grail of all the parameters that you can pass to control how crawler is going to operate. There are a lot of parameters, so that's why you wrap them into one class configuration, and you go to documentation, you're going to find a lot about it. For example, one of the things is the cache mode, cache mode. If you enable it and you send the same URL again, the second time root from the database. So that's one thing to remember. But if you want always get a fresh, results, you have to bypass it. By default, it's going to be bypass, and so, but if you want to enable it, you can just come and write enable. Then there are a lot of parameters, but one that I focus a lot is the markdown generators. We have different strategies to generate the markdown. This is the default markdown generator. And each markdown generator has its own parameters, but one that's very important is the content filter. When you generate markdown from a page, there are a lot of irrelevant noises that those things should be removed, like header, footer, like ads, like anything is not relevant. We call these things content filter, or they use an object and a class that's instantiated from relevancy content filter base class. And there's some interesting algorithm. One of them is the BM25. You can pass a query, and then you just get marked down for the part of the page that has information about your query. That's really cool, especially if you're crawling a page like Wikipedia. You just get paragraphs that has the information that you need. And the pruning content filter is my favorite one. It just shake the tree, pruning, and then just prune, and then what left is the actual beautiful markdown. And it's just like an example of how you can pass extra information. And then when you use content filter, you're going to have fit markdown, and markdown which is fit. So that is the second hello web. I think this too is good enough to get you a little bit into Crawl4ai. Okay, we reach to the end of this chapter, and then we discuss a little bit about the little hello web and the hello web and how Crawl4ai works. And then if we back to a slide, we are going to talk about the next part, which is how we want to build the SERP API or SERP API engine. And the first approach I'm going to use is the large language models, and I'm going to talk about it. So I give you a short breaks, and then we're going to continue in the next chapter. You beautiful people. That's what we're going to do now, is talking about building SERP API. And we're going to pick up the first approach, which is using large language models. So the code is here, or let me go to the code editor. But before that, let me a little bit explore behind the scenes of this page. I will go to inspect. It's always good, it's always good to make yourself familiar with the page that you want to crawl. I mean, don't afraid of it. It's much better these days than 15 years ago. I'm doing this sort of crawling for many reasons, especially automations. That was the first time I engaged with controlling browser. And I was working in projects in a company that its job was automations, testing softwares, and it was really cool, and I learned a lot. And that time was with Internet Explorer and using DLL, and it was so difficult and challenging. It's not like that. There were no any dev tools or Chrome, but I'm talking about the time before them. So, but anyway, it's good to get into the game. Now, look at that. We're going to extract the information of every one of these blocks, right? And we're going to ask large language model to do that. If I inspect one of this, let's say here, and then I go up to this level, okay, I see that. Let's a little bit zoom out. Okay, then I see that you see every blocks is here. So there are a bunch of the div elements, and then they're all into another div. And if I go higher, I see that there is a div with the ID search, which contains the whole results. You see that the whole thing, the search results. We are talking about, for example, it's an organic search, but we're going to extract this stuff later. And then when I open up again, I will see, for example, here. And if I go a deep dive into this, see, I have the dive, I have this, and all the information. Okay, so we're not going to dive into these tags. It looks maybe scary, but anyway, what we're going to do, we're going to give some information to large language models in an efficient way to extract this JSON for us. So this is the first approach that I want to use. The first approach, and why I call it naive approach, is because I'm not going to use any brain a little bit here, and I want to just act lazy. Lazy means that, hey, dear large language model, this is the HTML extracted from the Google boom, front of you, and then I want you give me something like SERP API. Hey, give it to me. Just act like this boss that doesn't want to do anything. Well, it works. It's going to work, but you will pay the price, and the price is the speed. Imagine you have an agents or assistants or an AI systems that have to find the answers immediately. Let's say you are doing algorithmic trading and then you need to fetch the data immediately and extract all the information. And if you're going to use the large language models and you're going to lose the price and opportunities to go in the market, that is wrong. This is not going to work. But anyway, I start from the first approach is a naive approach. Let us start to talk about it. We are here. And what I'm going to do is first I try to extract the HTML. Well, it's the most simple thing that will do that. And this time I use browser config. Well, I said the verb is true and headless false. The reason I put false is to see what will happen. I will show you one time and then I will turn it back to the through. Okay, then I'm creating async web crawler, and this time I'm not using the context, okay, just for fun. And what I do here is I'll just write try, and let's try, and then I'm gonna pass, and okay, Klaus. Okay, you see, that's what you're gonna do. You're gonna just work with your crawler. What are we gonna do? Try close block, and then just close it. And then what I do here, I will create crawler run config. And then let me first do the crawling, and then I explain that what is happening here. Okay. I'm gonna put like println result HTML. Okay, now always not, this is not happy. Okay, I guess there's, oh yeah, I found it. Okay, now let's dive into all these parameters, right? First, I'm creating my crawl config. The cache mode, we discussed about it, but look at here. This is very interesting because by default, the primary goal of Crawl4ai is to generate in the markdown. It removes a lot of unnecessary attributes that does not carry that much valuable information into the markdown. Markdown is mostly what we see, and we want to turn it into the markdown. So I can remove class and ID. Removing those attributes make the HTML much lighter, and algorithm works better and faster. However, in this case, I need them. Because if you look at the crazy HTML, a lot of class and ID, and these things are important. They help us, especially for the next stage, which I'm going to pick up the best approach. But right now, it's just like this. In this way, you can keep attributes. I keep ID and class. Then there's one more thing I like to keep is data attributes. Those attributes that start with the data, prefix data dash. And they are very important attributes. They carry informations. And we want to keep them as well because I think language model will use them to do some better understanding and reasoning. And finally, I'm applying some delay before return HTML. This makes sure that the page is loaded completely. In terms of the Google, I think 1 second enough, but I'll put it here. And look at now the search URL. This is search, and I add the Q. Q is the query, Apple Inc. And then I have a start and number. Start means the page 0 and number is 10. You get 20, you're going to get 20 results. And I suggest you to search about all the parameters that this has. It's a lot of parameters. You can just go and ask any large language models, they know it. Give me the table list of all cool parameters that I can search. In this way, you can set the locations, you can set the categories, image search, text search, a bunch of things that you can apply here. I'm picking up from now the easiest one. And I pass the configuration and then this. So let's go and run this one. I'll just comment or little hello world and hello web and this one. Okay, so let's run it. I'm gonna run if no error. Okay, you see the browser is here. Okay, I'll run it again one more time to see the browser. So Apple, okay, you see that was the page. Anyway, it just done the job, and then we got a very long HTML. Now, if I back and make this one true, well, we don't see the browser anymore. Okay, right now we're just getting the HTML. but we didn't do anything with that HTML. We want to extract the HTML, right? And then what we're going to do is we use now LLM extraction. LLM extraction is, okay, I'll give you the full code first. And then I'll explain in the code. When we want to pass extraction strategies, we do have multiple different extraction strategies on Crawl4ai. Extraction strategy, and here I have to pass the objects that I'm looking for. What I do is I'll come and I create, because we want to use LLM, we want to be a bit lazy, and we pick up the LLM extraction strategy, and that's what I'm going to do. Let's do this LLM extraction strategy. Okay. These objects get different parameters. One is provider, and I'll talk about provider in a bit, API token, instruction, a schema, extraction type, chunk token, and a bunch of things, okay? Base URL, there are a lot of things that you can pass. What we're going to do is, because underneath I'm using LightLLM. LightLLM is a perfect library to let you to communicate with all large language models in one unified way. So you don't need to be worried, how is the way that I can communicate with a Mistral or a Llama or this and that. And you can go to a page and then see the list of providers they're supporting. And so one way you're going to pass it, and it basically is the name of the provider and the name of the model, like OpenAI and GPT-4. If you can change it to a Llama and Llama 3.3, if Llama is running on port 11434, then you're going to be able to communicate with Llama as well. And then, or you can put Hugging Face. Yeah, I can do that. You can also here pass API token, but if you don't pass, it reads from your operating environment variable, which I do have it in my environment variable. Then some very important thing is instruction. Okay, instruction is the way you communicate with your language model, right? Extract the title, links, snippet, dates, and site links from the search results. Okay, that's a very, very simple way to talk. And then you can even say summarize. You can use it. You can use this LLM extraction, not just for the extraction. You can shift the data in the way that you want it. And it's good. Like any other language model, when you provide more information, you get a better results. And if the language model supports structured data extraction, you can even make it very deterministic by creating your schema. And anyway, all supported by Crawl4ai. What I'm going to do here, I will go with the very deterministic way first. We use Pydantic. Pydantic is a perfect library in Python that let you to do the data modeling and help you to create your classes, assign default values, descriptions, sexual descriptions to every field, and connect them like this. Look at that. I created a Google search result. Title is a string, link is a string, a snippet is a string, and site links, which is an optional. Not every search Google, this is site links, but this doesn't have site link, right? And then, so that's what is optional in the list of the site link. Now, what I do is simply, I can do this. I can come here and I say a schema is this. In this model JSON schema, convert the schema to a JSON representation of any schema. Now, when you work with OpenAI or any other model that supports tools or structured data extraction, you have to pass the schema. And this schema has a very specific structures. A nice structure that explain every field, their type, descriptions. The language model use that one to make sure that what sort of data that you wanted. But building that one is a headache, if you want to do yourself. So that's why Pydantic is really good. You just convert it to model JSON schema, you get that schema. And I pass it here as a dictionary. And that's enough, but usually, personally, I like to provide more information. It's just this, it's my own style. What I do here is, I tell you why I do that. I provide some information. I want to extract the title, link, snippet, and site link from Google search results. I shared here the content of, okay, I'll talk about this later in a bit. kind of from the search result page. We are just interested in organic search results. Example, links, and let me remove the date, and site links and all this kind of thing. Why I do that? Because not always you are using a very strong model like that. There are other models that are not very good, or they're not even supporting this way of structured data. So, but they have the capability to generate JSON for you. And underneath, I have done some adjustment that allows you to use this for any model, even if the model does not have natively or is not fine-tuned or trained to have the tool call or structure token to extract JSON for you. So that's why for those situations, to be more expressive and explicitly explain what you need become very important. And that's what I've done here. You see that? I'm explaining. Remember, these are language models, language. They are parrot. They like to talk to them, get them to the conversation, explain to them. There's nothing wrong with it. But again, as I said, if you're using a good model, just a simple instructions would be enough. I'm going to tell you that when you see someone says, hey, I created something, that you just say a little and you get a beautiful structured data out of it. Don't be naive. This you should ask that, okay, no, what if I want to make it more sophisticated? That should be your approach, not just the lazy part. Oh, so good, I'm just going to pad a little bit of, I want this and that ain't going to work. No, you have to understand the spectrum of different situations, because when you test on your computer, yeah, it may work, but when you go to the real wild world outside, when people ask for different and difficult things, then your app will crash, your software will crash. You need the variety of these things. So that's why here in the Crawl4ai, I support to just pass a little instruction, but also I support such a situation that you can pass a schema, you can pass instructions, then definitely going to work. And these days, we don't need to write this stuff. So you just go and open up Cloudy or DeepSeek or Mistral or QN or wow, there are a lot of them, right? And then explain to them, or Llama or anything that they're going to generate for you the structure that you're asking for. Okay, now we have some really cool large language model. And one more thing that I want to do is, at the end of the day, I have to pass this to my crawler run config. And that's it, it's going to work. There are a few other parameters I want to use it for this project to make it a little bit better. One is apply chunking. I want to make it false. What means apply chunking? Apply chunking means when I extract this HTML and I want to pass it to a large language model, I can set a chunk size, let's say 4,000, 8,000 tokens. And then I divide it between those chunks, send them in parallel to large language model. So in results, you're going to get faster results. That's a very cool thing. You can even set the length of that chunk. For example, you can put the chunk threshold, let's say 2 to the power of let's say 12, which I guess is 4,000 something like that. Okay, so, or you can make it like another one for 13 to go 8,000 anyway. And then let's make this verbose also true. We want to have it verbose. And one very important thing is the input format. When we extract the information from a links, we have different type of data, right? We have markdown, we have the initial HTML, we have the clean HTML. Clean HTML is much a smaller version of the major HTML, remove unnecessary, like a script tags, for example. And when you say input format, the default content goes through the extraction engine is markdown. In this situation, we don't want to convert the markdown. We want the HTML to be there, the large language model to see the HTML. And also, we don't want to go through the crazy big HTML. We want to go for clean HTML. So I'm going to write down the clean HTML. There are 3 types that you can use: HTML, markdown, and clean HTML. So every one of these three can be passed. By default is markdown. So anyway, when I say apply chunking false, that doesn't matter this, right? It's not important. But anyway, let me put what I just said, 3. Okay, so I'll go with the 8,000, and then or let me for now just say one chunk. Let's see what's gonna happen. Okay, then we do have everything ready. Okay, perfect. Now this time we want to extract the contents from the results. So what I do here is I check if result is success, then I will read the content of this field, extracted content. By default is a string, so it's a stringified version of that JSON that you're looking for. Then I load it, so I have now a dictionary. So I can save it in a file or I can print it. That's what we're going to do. Now I'm going to run the code to see how it goes. So let's run it. Oops, we got, what is that? I think that's autocomplete. Okay. What is, I have no idea about these things. Okay. Okay, now you can look at here, this side, you can look at this part. You see that we have one block because we set apply chunk to false. If we don't, then you're going to see block 1, 2, 3, and all of them running in parallel at the same time. But right now, I just called one. Now you are observing the issue with this naive, lazy approach, which I just rely on large language model. Even if you are using Grok, which is a very fast one, it's not instantly. You want to get the results in less than 100 milliseconds. That's what I want. I want it fast. Imagine it's just like quickly you have to make a decision. And every time you're paying more and you're engaging a lot of GPU for a data that is there. So what should be an alternative? And that's what we're going to talk about it. Okay, let's go to the HTML. Okay, you can see that it's generated for us some information. So I got those things from the page that we just searched and Apple Inks. Okay, let me back to my code. Okay, I will make this HTML. I think that better. And I'll make it like, a bit larger. So we're running the game. Okay. You see, when I put a threshold, and then this time I'm passing the whole HTML. Okay, look at what is happening now. We have 3 chunks. I think we crossed the context window. Interesting. So, well, it's a good experience. So we're going to back to 12. And then we're going to run it. So we're expecting more chunks. We're getting more chunks, and we'll see how it goes. We're using now, which model we're using? Okay, GPT-4o. Again, this is, those drawback of using a language model, because every time you have to keep calling, and the call is expensive, right? So we wait for the result. Then while we're waiting for that, also it's good to explain one more thing about the language model here. What we do have when you you see when you come here, you see there are some overlap rate, and it means you can have more variety on the chunking. When you chunk, you can overlap them to make sure that it contains all the data. Those kind of standard things when it comes to the RAG and its subs. So this time we got a lot of, okay, that's perfect. That's perfect. We got the information here. And if I go up and so you see we got a lot of information from the page. And now we can see that the apple, the site link is here. There's another apple. There's another apple with the site links. So that's what we are doing. Okay, so we got our HTML converted to our JSON, and it's reflecting the page, not necessarily exactly this one, because this is my own browser. This is coming from the browsers that in a headless open. And so this is the end of the first approach. So let's just a quick recap. We created a data modeling first. Then we called the model, we passed a schema, we created an LLM extraction strategy, we passed the schema, and then we explained what we wanted. And if you notice, I said dive search. One thing that I didn't do, and I could do it here, I forgot actually. I can say CSS selector and then pass this one. Basically, what will happen here is that we are cleaning, when we're cleaning the HTML, we just pick up this part. And then here, to make that one work, you have to use the clean HTML. And this is a smaller one, so you save a lot of tokens, and you get the job even faster result. And if I run it, even you can see. So then we discuss about what is a good way of using the LLM extractions by passing instructions and the models and all those kind of things. And then you see that this time using one block works because the size is small. We just pick up the organic search results. And then the crawler config, in the crawler results, we save the results and we talk about extracted contents, and that's it. So we done the job, but not in a very smart way. And that's what we're going to do in the next chapter. In the next, let me make sure the next chapter is, we are here with it, with SERP of the NAI way. Yeah, it's the real word example. Okay, great. We're going to go through the schema. Okay, perfect. So that was this chapter. In the next chapters, we're going to talk about building in a schema from the HTML, but without manually and pain-free, and you will see how it goes. And then after that, we dive into the best approach of how to use large language models one time, create a schema, and do the job. That's it. So just a minute break, and we're going to back and continue. Okay, now, since we discussed about using a large language model, and I want to get into the better approach, the approach that I prefer to do that. It's cost effective, and not only cost effective, it's super fast. To get you ready for that, I first want to bring your attention to the HTML behind the search results. Let's go back to Google website. Well, when we inspecting, the idea is this. No matter what, when you go to every page and you want to extract those structured data, most of this data are coming in many situations. Data already has a structure. For example, when I look at the Google search results, it clearly has a structure. It has title, it has the links, it has site links, and everything is there. This is very different than a situation that this is you're facing with the unstructured data. And then you need large language models to process, to extract it. Information extraction been a part of NLP for many years. Even my thesis and research was at university was about information extractions and a lot of algorithms and techniques to turn unstructured data to structured data. And it was very difficult. And now when you use a language model to just do that, it's funny. So this is not the case. If I give you a text, let's say you do have an article and author is talking about some important topics and you want to extract and build a knowledge graph, that's where you need a large language model because the structure is not there and you have to impose the structures. It requires understanding of the language. But when we do crawling many times like this, there are repetitive patterns that we can detect and give it to the language, give it to the engine, and then extract it. And these patterns are basically HTML. And when you look at the HTML elements they have, how you detect the pattern in the real world. When you see repetitive patterns, you find some traits, some characteristics. And those characteristics, when it comes to the HTMLs, are class, IDs, their positioning, very important. And the depth of, for example, when we start from the body of the HTMLs, we go deeper and deeper. That is the depth. You can use exactly the location, and that is XPath. For example, look at here. Let me bring this. If you right click on an element, let's say, okay, you can see that when I hover on these div elements, it shows a div that contains the search results. If I right click, you do have a copy, and then the copy, you can copy the HTML, you can copy the XPath. XPath is a unique address that pointing to that element. Well, if you one way of thinking is, okay, I will extract the XPath and I will use any HTML parser and I pick up my data and then I'll iterate it. This is a typical way to do that, right? And the problem here is many other times these websites, they change dynamically, they change, the content change. And not always easy like that. You know, we're just going to go and dig in and find a lot of things. It's a little bit ugly job and it takes time. But anyway, that was a solution and that was the way people used to do that. So now we're going to figure out, can we use language model to detect the pattern, create an intermediary schema, then we use that schema to extract all the informations without any language model, just quickly using like XPath or CSS or selector or that kind of things. So this is the idea. The idea is what I do manually. I come here and say, okay, it seems every div that has, let's say, look at here. I open two of them. I open two. If you notice here, I'll try to zoom a little bit. Okay. If you notice, do you see that this div has the class G? This div has the class G. So it seems that all the divs that they have the class G, they carry something important. Let's try it. Let me bring this to, okay. If I write the documents, and document refer is a JavaScript. If you're not familiar, it's not difficult that much, but query selector, it gets a CSS standard CSS selector, the way that we can refer to elements. So I can say that the div, any div with the G. So when I do that, you see what I get? I get all these div. It's very interesting. You see that I will get back all the kind of div that they have the G. And if you look at this, this is referring to all the search results. That's really interesting. And then I can get into the game. So you see, I found a pattern. But again, we're not going to do this ourselves. If before large language model, yeah, we had to do it ourselves, or some sort of other heuristic techniques was around. And if I open up this, I go now deeper and I will find, okay, so you see that I have this, I'm just keep going down and down. And then, or of course I can use the inspector and I click on that and I will jump to this one. So one thing that I can say, you see this is H3. What will happen if I repeat this selector and I write down H3? And this time I'm getting all the title, right? And if you are familiar, for example, with, because this is node list, you see that is a node list. And if I'm, okay, let's say array from, I think this is going to give us an array. And then let's say pick up one of them. And so you see that it gives me the text, right? I can even go with the 2 in the 3. So this is the idea that what I can study the pattern and those parts that I wanted, like title. For example, if I want to go for a snippet, let's see what will be the snippet. I will go jump and pick it up here. And then we do have a span. And okay, so we do have this. So you can think maybe it's in a span. Let's try it. I try to write span. But not all the time, right? You see that it's not necessarily just in a span, a lot of a span. So I have to become more specific. I'm getting you familiar with issues, been around with these techniques. I can say, okay, maybe just one of them. Maybe it's, I have to be more specific about div, maybe. So it's like that. For example, let's say I pick up this one. I don't know. I just pick it up and I will come and write down here that, this span, and, I'm getting a little bit of more, but it seems like more span. You see, it's detecting everything. So that's you can see the difficulties. For example, I can come and I take all these classes and I just say, what if I do this? Look at that. I say dot, and dot means I'm looking for a div that has all these things together. When you put a space, it means, oh, see something happening. Let's look at that. And let's pick up, like, say, the third, then the inner text. Yeah, we got something. We got the text. So that's fun. It was fun. Trust me, it was. I know it looks challenging, but it was fun. And also it's like a deciphering, like a decoding. Oh, I found it. I remember that was very fun. Anyway, now the idea is this. What if I can find all such selectors? You see the part that in the orange color, selector, and then extract them one time. And then I go through the page and iterate and extract everything and then build JSON. This is the idea. So if we can somehow eliminate the need for human to create these patterns, we have a bonus here. And that is when and where you need a large language model. To look at the HTML, you explain what you wanted, and they are very good to understanding the text, especially text like code, like HTML, better than human text. And they generate for you that schema. This is where you have to use it. So that's what we're going to do that. Crawl4ai has generator for a schema. You pass the HTML, you explain what you wanted. Try to give you a perfect schema. And then we use that schema with another extraction strategy, which is the JSON CSS extraction strategy, and voila. So it's only one time you use language model. And then you may say, so, but how about the problem of these things keep changing? You're right. Then this process of generating the schema, you can running every 24 hours or every 1 hour. Or basically there is a technique that you understand the page content is changed and you run it again. It's on demand. It's far lesser than every time you need the data to do that. That's the kind of thing. So especially for pages that their data is changing, like the Google search and the content of the data. So that means every day you need to access, or every hour you need to access. It's not only one time. So you can say, okay, one time I use language models to extract all the details of these articles from this page. No, it's when the page become more dynamic, you have to be also more agile. So with this explanation, we're going to back and we're going to do something interesting. What I have done, I came here and let me go to elements. Okay. What I did, I just came and I copy one of these elements. That's typically what you can do. It's the best way. Just find the elements that is repeating, and don't go to very details. Don't narrow it down. Don't go deep. Come to the highest level. You see that after this, it's now the whole div container. So I pick up this one. This is good enough. You right click and copy the element. And then you come and paste it in a file. So I paste it here. Just saved it in a file, is a file, I save it. And then now I will back to my schema generator. Okay, everybody, get ready to build a schema in a magical way. I will just paste the code, save the time. So what I did is I saved the file. This is the file that I saved. You can just paste HTML here, but it's big, so I just wanted to make the code looks beautiful, not ugly. So I saved in this file and I copy that HTML. Then I call JSON CSS extraction strategy generate a schema function. It's a static functions. JSON XPath extraction strategy has the same functions. LLM extraction has this one. I forgot to talk about it, but in another video we'll do that, which basically it can generate that pydantic schema. So you don't need even to create the pydantic schema yourself. If there's a situation you want to have dynamic structure, it will do that for you. And here we pass the HTML, and look at this. Here we do have this target JSON example. You just showed the target of the data that you wanted, and I'm trying to mimic. Okay, so I'm trying to mimic the SERP server. So try to look at it here, and that's what I'm trying to do. So from here, I took that one. I even go even further. For example, the date is 1 hour ago. It's just a kind of understanding of how fresh is the data. You just put it here. You see what I did? I just simply, this doesn't have any specific rule. I don't have any specific rule. Usually I use like that, but you can be creative. You can, do more stuff. Who knows? And then, you know what? Because this is actually a language model is in the game. Okay, I'll talk about it in another video. So here you just say the target JSON example, and I do have a query. Query is important. Query because you basically explain. It's important. Explain to your model that what you are looking for. And remember, I told you that when you talk more with the language models, you get better. The given HTML is the crawl HTML from the Google search results, which refers to one HTML element representing one organic Google search result. Please find a schema for the organic search item based on the given HTML. I'm interested in the title links. It's just a basic conversation. You can try. You can try without this. It should work. But I like to talk. So, and then after that, I'm just gonna print it and save it. Whatever. So let's try this code to run the code, and then let's make sure that this is off. So we're here. Okay, I'm running the code. And remember that this time it uses of course you can set again provider, other stuffs, API token, whatever you want, but make sure to pick up a good model. A model that means it has trained on understanding JSON structure. You can play around with different models. But because one of the benefit of thinking like that is it's one time. So you pick up a very good model. You can do that and get a good result. I'm running this. Okay, we got look at here. It took the same thing that I found by myself. Very interesting, very efficient, very efficient. It chooses names and give you the field. For the title, go for the H3. For the links selector is the A. That means there's only one A over there, and it makes sense. And then a snippet is this one, and then we go, and the date is span F, and we have these site links, and within the site links, the selector is this. These are each one of the site links. And then we pick up each one of them. So this is the immediate child. That means the first one. And then, okay, so we got in a schema, right? We got in a schema. So you can save this one and use it later. So this was about how to generate a schema without, I can't say without human intervention. What I mean is with a very minimal intervention. And again, you can do the whole things, automatically. You can just call the Crawl4ai, fetch the HTML, use a CSS selector, pick up the HTML from the part you wanted and pass it to this function and get it. So I don't need to remind you that you don't need to go necessarily. You can't go to the browsers, right click, but you can do the same thing with the Crawl4ai as well. Depends on which one is fast. But again, we do this only one time. Perfect. So the end of this chapter, and then the next chapter is using this knowledge to build up and mix everything together to create the golden solutions of extracting informations and having our own free SERP API engine, SERP. So that's it. Let's have a quick break and we continue the next chapter. Okay, everybody. Now I think we're ready to finally do the main part, the core, building this SERP search engine with all the things that we have learned. The idea is this. We fetch the HTML at any time. Then we already created the schema for everything. We're going to do that. We also can regenerate the schema on the fly. Then we use those schema to extract all the HTML. So there's one sending HTTP request to the Google page to get the whole thing. I mean, using the browser. Then the second is nothing. If you already have generated a schema, so you just use the schema to extract all the information. And then that's it. And then let's say every 24 hours, every 1 hour, or depends on your situations, you can refresh your schema. This is going to be the structure. So let's jump to the code. I have two functions. One is the search function that get the query and then returns back a dictionary. And then I do have this build a schema that get a HTML. I'll call it HTML. And then there is a force. You will see what I mean by the force later. And then it builds a schema for you. Okay. And what it does, you can see that it returns a dictionary. And then what we're going to do, because we have multiple schema. One schema for organic search result. One is schema for top stories. One is schema for what other people searched, top queries, whatever you want from this page. So we have multiple different schema or the data extractions we're going to have it. Here, if I, okay, you see that, oh, this time we do have some topic stories. Beautiful. We have topic stories. And then, because sometimes there's no topic stories, and today we have topic stories. As far as I know, the serper does not return topic stories. I don't know why. Let me search again. Yeah, it's not there. So, but we're gonna have it. We're gonna have it. That's what I'm planning. Well, let's start with this. I already created the code, so I paste and then we'll discuss about it. Let me first start from the organic, then you will understand what patterns I'm following. I want to save this schema on the disk and then refer to them in my consecutive call. And if there are schema already generated, I don't want to do it again, right? So I have such a kind of code. So let's look at the first one. I first searched that if there is such a file, organic schema JSON. So just simply read it, and then I have this schemas, and then I'll do the organic, and I load it, and I there. So this is a very naive way to do that, right? If you may, in your applications, you may want to do the database, you may want to, I don't know, whatever you like to do that. And then, or maybe you have a cache, and then you can check that if there's a TTL, for example, if from the last time that you saved, it's already past 1 hour, you want to again go through creation of the schema or 24 hours. So there are a lot of things that can be done in the real production. And then, and you see that I have the force, but seems make the force be with you, but it's not with me. I think I haven't used it. I mean, like, or, so let me see if GitHub Copilot can get it, or force, yeah. So if the force is true, then it means, oh no, or I have to do this. And not force, okay? And then because if it's force, I want to go and I do, if not, the force is not with us. So we read from the stale data. And then here, we're going to do is, okay, remember I have the HTML, like what we did before, but this time this HTML is the whole page HTML. That's, you remember that I told you, I right click and I took the HTML of that section. Well, this time I passed the whole HTML, and you can see the capability that can do that. Remember I told you you don't need even to do that, but that's here. You just pass it and the model can understand. Okay, what I do, I just the same thing, and nothing changed. So it's just basically the same thing. And at the end, I will also store it on the file. And that's what is happening. Now I repeat the same thing for, let's say, topic stories. It's very simple. It just continues as long as you want it. Let me put the topic stories, and then you can see here I do have the topic stories schema and then topic stories, and I have a different structures for topic stories, and I have some explanation, and then nothing beautiful. It's just replication of this stuff. And again, in production, I do definitely a different way. I tell you in a bit. And this is for, I guess, topic stories, or it's the suggested queries. There's that suggested queries. We're going to take it out. And suggested queries, we're just only interested in the query, nothing more. Just like that. Okay, and then why is suggesting me something different? Okay. And that's great. And we return back the schemas. So I created 3 schema. If in the production, what I do is the whole thing can be iterative. What I'm trying to say, that look at that. You see, this is redundancy. This code, forget about those orange color, is the same as this code, and is the same as this code. So what I do is I keep them in a database, no matter it's a JSON database, a memory, or file, or whatever. These are like a schema. Every schema has a name. So you can imagine a table, a schema called a schema name column. Then it has in a string, which is a targeted JSON, that's the second value, and it has the query. So you see what I mean? Now I have these rows of each row is one schema. I iterate and I call the functions for that. And if I want to be super smart also, I do it in parallel. I run in the parallel because these are all I've written the parallel, and then I will get the best out of everything. In this way, dynamically in your database, you can go and add a new updates, and then you will get it. Imagine if you're building an application that has user interface for the user, you can do such kind of things that you can building up and then pass it here. So you see that when I say production, it's not more about writing a better code. It's about thinking like a system designer, thinking along. That comes out of experience. But so I encourage you to think and incorporate the library this way. Otherwise, you will face with a failure and you think your tools has issue, or you think the library has issue. The way you utilize it is important. So I hope this example gives you an idea of how to think. And so again, this is a naive approach, and I'm just building up quickly. And I think, okay, we got now these functions. We have our own functions. These functions works nicely. I already have created this schema. So if I call these functions with force false, without force, boom, I'm going to get it. And now we go for the second function. Okay, this is very interesting. If you remember that when I do the crawling, when we create crawler run config, we can pass extraction strategy. And in this case, we're going to go for JSON CSS extraction strategy. And it's a one strategy. What I mean is we call the HTMLs and then we can pass one schema, because currently the LLM extraction strategy or JSON CSS, all of them, they get one specific schema and they iterate and extract it. And now while I am creating these projects, this came to my mind that I add in the backlog that can get multiple schemas and can extract all of them at the same time. Why not, right? So it's not like that right now. So we have to come up with a better way. You may think that, okay, I call the crawler run functions 3 times, and every time I pass different schema. Well, yeah, you can do that, but it's ugly. You just keep launching a browser. It doesn't make sense. So luckily, there is a good solution, and I will show it to you. First, so what we do is, again, we're going to just create our own stuff and then try, and then we're going to have pass. Let's have the finally. Okay, all good. And then we're going to create our crawl run config. And okay, so that's the crawler run config. And oh, yes, no, I'm not. Well, it's good. Okay, we need to wait for that. Okay, result. You know, I like to use the type. Okay, and then but there's one thing we have to do first. So this is same things. I keep those IDs and delayed and And this time I want to import functions to encode the query. So you know it's going to be like that. And this is wrong because I need to use this approach. Let me do something here. Okay, better. So we do the search, and you see that you can come up with more creativity, you know, parameters in this. And now we do have the result. Okay, I didn't use any extraction strategy. I just got the HTML, and this is where we're gonna do interesting stuff. Look at the code. Let's think yourself. I am fan of strategy design pattern. I am fan of design patterns. The 23 famous design patterns in the Gang of 4 books came out, and I was teaching at university for 3-4 years, all these patterns, and it was so good. In C# I was teaching, in Java I was teaching, in basically static type languages. And then when I was working with interpreter or dynamic type like Python, like JavaScript, then some of these design patterns, they changed, they evolved. But at the end of the day, it was beautiful building blocks. It led you to think beautifully and build software that can be minimal and can be strong when you want to change it. And one of my favorite is a strategy design pattern. That means you can build, for example, I know that I like to have different extraction strategies. So I follow strategy design pattern, and in the results, I have this ability that whenever I came up with a new idea, I can create it. And every new strategy design pattern has same interface. It means they have same struct, they have same functions, they have same outputs, but inner the strategy will be different. And the good thing is that you can use them directly, independently than the main engine. And that's what you're going to do here. If it wasn't for that, it could be very difficult or complicated. It means that I can use LLM extraction strategy separately or JSON extraction separately. And that's what we're going to do here. So let's do it. I'll just paste the code. Let's see what is happening here. I check if the result is success. Then what I do, I call build a schema, the function we just created. I pass the HTML and I will get the schema. So all the schema here, right? Nothing important about it. Then I move through this schema and now look at what is happening. I come to search result and I pick up a schema name. Why I'm doing this? Because if you remember that here, we're getting a name like this. So I like to convert it to a lowercase and replace, with this to build a kind of key is just a quick way, thinking, but the better way to do that. Anyway, but just for now. So I call it, if you like to think about the schema key. Okay. Okay. And then I create JSON sys extraction strategy and I pass the schema to it. Then I have this run function. All the extraction strategy, they have this run because they're following strategy design pattern. And for the URL, I don't pass anything. And then this is a specific case. We don't need to pass anything for the URL. But it get a second parameters, sections. Basically, you can pass multiple chunk of text and it goes through each one of them in the parallel and extract all the elements. So they're designed to be like that. They're designed to accept, to be efficient. But in this case, we have only one HTML. We want to do that. So I have now the schema. I have this, and I can get them all. And I expect the result be the JSON, the JSON that I wanted. And you can see, look at the definition of the run. The output is a list of dictionary. That's why it's nice. So what I can do here, maybe I can be more dict is str and is list. Yeah, so it's going to be like that. It's the key is string, the name, and this is a list of extracted elements, top stories, whatever. And then here I'll just, and you know what, this is super fast. Extremely fast. There's no large language model here, nothing. And then finally we're going to save it and ta-da! And then we may what we're going to do is, okay, where is the results? Search results. Okay, so what I do, I'll create this maybe somewhere here for now, and then the end I return search results. Perfect. That's it. We just built it. I will put a breakpoint here because I want to show you guys that how the build schema work. And oh, okay, what I'm doing twice. Okay. Okay. Unnecessary declaration of variable. It's very right. If you do that, you are removing, when you write q equal by code q, what is happening is you are basically when you write a code, the code will be converted to intermediary code, like a bytecode. And that bytecode in interpreter languages or in local or native languages, or it will be machine code. The code for this is larger. So this means you lose some milliseconds in the algorithms. You're calling functions and you're having an assignment. And this unnecessary assignment required more tasks. You can think of it more in CPU instruction. Well, you may think it doesn't matter, but it matters a lot. So, especially when you have many of them, when you run this in a million, and that million times 10 milliseconds is a real number. Okay, I think we're ready. We're ready? Schema generator. Let me just copy this one and okay, perfect. Sounds good. And what I will do is I'll come here and I run it. So let's see what we're gonna have. We expect to fetch. Okay, we got it. What is this? Doesn't have what? A run. Okay. So you see that for it probabilistically it make more sense to be crawl rather than a run. That's very interesting things. So I have the build schema and I will go to the build schema function. And because there is such thing, so I'm loading that one, I'm returning that one. You see, it's just a very quick way of, because I already called functions for all of them. In your case, you're going to run it the first time and it will take a little bit of time and then you will have all the results. So now look at this part. I have the schema key, which is a Google search organic search results. And this time we run it. Boom. And done. So let me put the breakpoint here. Okay. You see, it's done. Trust me. If I go to the search results, it's all down. We have top stories. We have Google search organic search results. We have related stories. And I print it and I just let it go. Okay. Beautiful. Nice. We got also top stories. You see, we got top stories. That Alibaba thing. It shorts its 4 months high and the AI partnership news. And it's all about the Alibaba. Apple renewed the Gulf of Mexico, Gulf of America. Okay, Apple interesting. So these are our top stories, right? And then, so let's just a quick recap what we did. I forgot about my slides. Real word, yeah, we talked about it. A schema generator, we talked about it. A golden points, we had the code, we talked about it, yes. It sounds good to me. And then what's the next? Oh, okay, the next is this, okay. So just a quick recap before we go to the next chapter. We build a function, build a schema. We use our knowledge on just pass the HTML, explain what you wanted, and get a good schema and save the time and don't run LLM again and again. That's very beautiful, very beautiful. If you are paying money for your business, you understand this. So, and then we store and use them to extract all the informations. And the very important thing is that I didn't use extraction strategy within the crawler one. I use them separately. This is a good thing for you because you know that you can use these tools in basically Crawl4ai designing like this. Everything's like this. Markdown generators and this and that. You can use it for the offline files in any way that you want. And not necessarily you have to go through the arun function. And it has its capacity. And that's what I did it here. And we did it, finish. So what we're going to do now, after this, I'm gonna explain about something very interesting new coming, which make these stuffs easier and let us to share our ideas with each other. And then the last one, we'll do have a recap and the whole thing is done. So let's have a break and we continue. Okay. Now in this chapter, I'm going to get you familiar, introduce the crawler hub concept. It's the very beginning of it, but I'm very excited about it. I think by now you are, if you are a programmer for even 1 year, you are familiar with the concept of the hub. For example, look at the Docker hub. There are a lot of images. People create image, they push it there, you can pull and you can use it. Such kind of concepts let community create content, drives community content. People create and other people, they use it, including GitHub itself. It's a most important example is the GitHub. I don't know why I didn't start with the GitHub and I started with the Docker. Well, maybe because we're releasing a very good Docker for Crawl4ai. It still is in my mind. Now, what I want to do, I'm starting to build a crawler hub. Look at what we did today. We built a process, a pipeline that generates such a JSON. And it's useful. This is useful. This means utility value. And then we want to share it with other people. And what if you are in rush and you don't want to do that, so someone else has done it and you get it? There are many ways you can create, for example, a gist in GitHub and then put there and then share it. But I wanted to build in a kind of structural way within the Crawl4ai. So I am bringing to you Crawler Hub. And right now has one example, which is this Google search. But how you're going to use it, you can imagine, and how you can contribute. It's in a very experiment, and I will show you the code here. I'm testing it for now, but I will release it soon. And let me put the query. Okay, I release it soon, and then I'm really excited to see what you guys will do and help and support and engage it. Look at this one. We're going to have this crawler hub. This crawler hub gives you access to the remote. You can imagine if there are lots of such function that they do different things. For example, Google search, right? So what you do is you just call them. This is like importing, like download for you from the remote, and then give you a class variable. At this phase, the hub comes with the library itself, and either you install the library or you clone the repository. But if I see the engagement, I already have done everything, make everything ready, it goes to different repository. So we're going to have a second repository for all this hub, and it fetch from the online. But for this phase, it comes with the library itself. So that's a good thing for the start. And then what you do is you just call the name of that particular crawler. And now you have the functions. You create an instance from that class, and you see crawler, and everyone come with run function again. So that's it. And then you can imagine that one of these crawler has a documentation, has metadata. Actually, you can print metadata here, but I want to talk about it in another video, but I'll just show it to you. So simply this, for example, let's say someone created a Google search and need a query and also accept search type. The one that I actually created has the search type image as well. And then you see there is every crawler has different parameters, depends on the need. In case this crawler has this third parameter, it says where you want me to save the schema. You remember that we save and cache a schema. By default, it go to the home folders. I mean, you don't need to pass this one, but you can pass it. But anyway, that's it. You just run it and then save it. This is the beauty of the crawler hub, everybody. And imagine if you guys create a lot of them for different pages, websites. There are a lot of them, and you just push it. And the push also is very simple. You can there's a command line for that, and then other people will use it. And if everything goes well, I want to build it like a kind of community. That means we can have the best crawlers feature you in creatings, and people come and search on different categories, different kind of data, and it would be very interesting. And I'm very excited about it. So in the new version, you will be able to use this one. And I'm going to bring this to the series of 0.5 versions. You just run and then get your crawler, pass the parameter, and then finish, and then get the result. It's really cool, right? Because it led you to focus more on what you want to do. Okay, so we're done here, and we want to end up by recap the whole things. Let's see what we discussed. Okay, we discussed about different stuff. First, we reviewed the SERP API. We went through the dashboards. We talked about different things. Then I show you a quick demo of what we're going to build together. Then we studied the HTML behind the Google search a little bit, and we tried to understand it. And then we used the naive approach. passing the HTML to a large language model, and then just say, hey, do it for me, like in a kind of dreamy way. It did the job. That's a good news. But we discussed that why this is not efficient for such a scenario. You have to use language models in a proper way, not just in a steroid way. It's not an steroid. You have to really work properly. So after that, we jump to building in a schema. We talk about the HTMLs. We use the Chrome Dev tool. We saw the difficulties that we had before. And then we learn how to use the Schema Generator feature in Crawl4ai to use LLM to build in a schema. This is a proper use of the LLM. Then we use that knowledge. We create functions to extract different schema that we wanted, top stories, organic search, or we can go and add more stuff. And then we extract those things. We build this schema. Then we use it in our search function. And also in the search, we discuss about the strategy design pattern. That means we discuss about, okay, we have different schema. Why we can only get HTML one time and then use the strategy directly and create and extract all the information that we wanted and save it. And finally, we discuss about a crawler hub, a new coming features that let you collaboratively create all these kind of things, push it, and people use it instantly and have fun with it. So this was a very long video, and I want to create more content like that. For those of you that really want to work with the library seriously, so if I create a short video, my goal is more like getting people attention. But when I'm creating videos like that, is for those already attended, I want to make sure they use the library in a proper way. So I feel it's not just maintaining the repository. You have to really educate the consumer of that library in a proper way. And so the time that you put here, the time that I put here, hopefully can turn into assets and values for whatever your guys are creating. So I hope you have fun. I hope whatever you create turn into the next viral, beautiful, awesome things. Not necessarily viral, even not viral, something good, something that you can have fun with it and giving more fun to people, and do and give credit to Crawl4ai in your libraries, in your pages, and everywhere. And that's it, I guess. Let me see, is there anything else I want to announce? Because always when I finish the recording, oh, I should talk about that one. Oh, I forgot this. It's a kind of common thing. So that's it, everybody. I guess we did a perfect job, and I hope you had fun with it. And that's all. Unclecode out.